Let's check the section 6.4, assessing normality. Okay, the distribution you have seen up to this point have been assumed. Oh, sorry. Okay. Has been assumed to be normally distributed, but in the real world, maybe it is not. Okay, and how do you determine if it is normally distributed? One way is taking sample and look at the sample to determine whether it appears normal. If the sample looks normal, then most likely the population is also normal. Okay. If the sample looks normal, then most likely the population is also. What does it mean? Okay, why we learn statistics? Because technically, economically, it's very hard, it's impossible to get all information from the population. Thus, we need to select representative samples. And now, why? Because the sample number is smaller than the population. It is feasible, economical, and easier to do that. If the sample smaller number looks normal, then most likely the population is also normal. Okay, here are some guidelines. They are used to help make the determination. First, histogram. Make a diagram of histogram. For normal distribution, the histogram should be roughly bell-shaped. Again, roughly bell-shaped. For small samples, this is not very accurate, but another method is needed. The distribution may not look normal distributed from the histogram, but it still may be normally distributed. Okay, let's check the diagram later. Okay, outliers. For normal distribution, there should not be more than one outlier. And one way for checking outliers is to use a modified box plot. Outliers are values. They are shown as dots outside of the rest of the value. If you don't have a modified box plot, outliers are those values that are above Q3, the third quartile, and an amount greater than 1.5 times than the IQR, like this one, below Q1, the first quartile, and by the amount greater than 1.5 of the IQR. Okay, let's check here. And third, normal quartile plot or normal probability plot. This plot is provided through statistical software on a computer or graphing calculator. Sure, later I will show how to find it. Okay, if the points lies close to a line, the data comes from the distribution is approximately normal. If the point do not lie close to a line, they show pattern that is not a line. The data are likely come from a distribution that is not normally distributed. Okay, let's check. I know you may get confused. Okay, just check here. After the textbook, for example, the textbook give this example like this one, and like this one, very close to, should be close to a line, but it didn't. Okay, and this graph looks more likely an exponential growth than linear. Okay, and now let me show you how to do this. For example, when we search statistics normality calculator, we got some useful free online calculator here, and I use this one. Okay. Again, you can search it here, or you can use the website I suggested. Okay, please do this first. I use this one. Oh, this one is also okay. The line? Yeah, I did send the link here. Oh, okay. Okay, then here, if we select the numbers here, copy, Control C to copy, and paste it here. Paste it here, then click Analyze. Click Analyze. We got the answer here. There are 64 values. The mean is here, and the median is here, and standard deviation is here, and the range. What does it mean? The range from small one, biggest one minus the smallest one. Okay, and skewness is one, and we got the value here. So if the number close to a line, it can be considered as normally distributed. But from this textbook, the exam for the test is not linear, so we don't think it's a normal distribution. It impossible to be a normal distribution. And how about this one? The bear-shaped curve, and the distribution, we know the smallest one is here, the mean is here, and this distribution is unlike to be a normal distribution. Is it okay? Sure, you can try this to the next software. The second website show the similar results like this one. The distribution, the bar looks is not a normal. Very strange. And those two one we consider they are outliers. They are outliers like this one. Thus, we consider the value here is not a normal distribution. Okay. Like this one. Okay. And how about try this one? Try this one. Example 6.4.2. Yeah, please try this one. Copy and paste to the website. Okay, I make a copy and paste it here. The second question and analyze. See, the count 50 numbers and the mean and the median very close. They are 96. Standard deviation 13, reasonable. Range 60, skewed, very small, very small. Let's check. Wow, perfect. The second example, the bar diagram very close fit the pear-shaped curve, right? And the spot very close to a line. Then we can think the second example is a normal distribution. Okay. Okay. Close to the end of this class, I have a mission. I don't say it's a homework. Can you generate random numbers by the computer? Sure, we can do it. You can use Excel, Google Office, but can you generate 100 numbers? They are normal distribution number. Do you understand my question? 100 numbers or 1,000 numbers? 1,000 is too many. Okay. You can use Excel or Google Office to generate random numbers, but now it's very easy. And now, can you generate 100 numbers? Those numbers are normal distribution. Can you do that? Sure, you can type the search engine. Can I generate 100 numbers? They are in a normal distribution. Then you got software. I will stop here. Then maybe you can do that. Then you can use the number simulation, run this software. Okay, I will stop give any teaching now. Any question, please let me know. Please do the notes here.